All right, so let's come back and let's try another one. So this will be our third example. So this time let's solve for sine of theta over 2 is equal to 1. And again, let's do it over the interval 0 degrees to 360. So let's change it up a little bit. So we can see that this is technically a half angle. So this one's going to be a little bit more challenging, though, to use our half angle, because our half angle identity writes like this: 1 minus the cosine of theta over 2, right, is equal to the sine of theta over 2. And again, we don't really know what the cosine of theta is. So let's not use our half angle identity. So I'm going to go ahead and take that away, erase it so you can't see that I did that. And again, I'm going to write a quick little let statement, so change it up. So we're going to say this time let's let x equal theta over 2. So this will just become the sine of x is equal to 1. So this seems like a pretty easy answer. There's only one answer. X has to equal 90 degrees. So when I set up my equation, I'll say x is equal to 90 degrees plus the 360 degrees times n. I'm going to replace x with what I found out it was. So theta over 2 is equal to 90 degrees plus 360n. This time I'll multiply both sides by 2. And so our 2's are going to cancel out, leaving with just theta. 90 times 2 is going to be our 180. And then if I multiply 360 by 2, I should get, what, 720 n degrees. I want to plug in some numbers. And if you think about it, this is already outside of my domain. So the only number I can plug in is when n is equal to 0. So when n is equal to 0, everything's going to cancel out. And I'll get 180 degrees. All right, if I do n is equal to 1, it'll be 180 plus 720, which is way outside of my domain. So half angles, you'll definitely have less answers than when you have multiple angles. All right, let's try another one. So why don't you guys go ahead and pause the video and try solving this one. Tangent of 4x is equal to 0. And again, we'll say over 0 to 2 pi. So pause the video and see if you get all of the answers that I'm about to get. All right, so if you're coming back from paused video, let's walk through our steps. So the first thing I'm going to do is write a quick little let statement. So let theta equal 4x. So tangent of theta is equal to 0. There are two answers if we think about it. So theta could equal 0 or it could equal pi. These will produce the same answers, so we're just going to go with pi. So I'll set up my equation. So x is equal to 0 plus n pi. Not theta. I meant to write that. So theta is equal to, then I'll replace theta with my 4x, so 0 plus n pi, divide everything by 4, so I'm going to get 0 plus n pi over 4. Now what happens if you had written this second equation, right? You would have theta is 0 plus, or not 0, pi. Plus n pi, and then 4x is equal to pi plus n pi. Divide everything by 4. So x is equal to pi over 4 plus n pi over 4. So I'm going to show you that we're actually not going to need this side. So we don't need, okay? So let's go ahead and let's plug in some numbers we know. So when n is equal to 0, so when I plug in n is equal to 0, 0, 0, so my first value is going to be x is equal to 0. When I plug in 1, 0 plus 1 pi over 4, so x will equal pi over 4. Plug in n is 2, this will become 0 plus 2 pi over 4, which is the same thing as just pi over 2. Plug in n is equal to 3. This will become x is equal to 3 pi over 4. I didn't find my domain. My domain is 0 to 8 pi over 4. So let's keep going. When n is equal to 4, x is equal to pi, n is equal to 5, x is equal to 5 pi over 4, n is equal to 6. Ooh, we can keep going. So 6 pi over 4, or aka 3 pi over 2. N is equal to 7, x is equal to 7 pi over 4, n is equal to 8. I'm going to get 8 pi over 4, which is 2 pi, which does not work. So I get to stop at that point right there. So all of my answers, let me write them in order. So 0, pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2, and 7 pi over 4. Notice how many answers we got. 1, 2, 3, 4, 5, 6, 7, 8. We got 8 answers. And notice what number we had in front of our tangent. We had a 4, right? Kind of interesting to use those multiple angles. If we think back to the very first example we had, we had a cosine of 2x. And notice how many answers we had. We had 4. 1, 2, 3, 4. And then our next example, we had 1, 2, 3, 4, 5, 6 answers. And there was a 3 in front of our cotangent. So that multiple angles does tell us how many numbers our answer should have. Now, why didn't we actually need this? Well, if we think about this, if I plug a 0 in to this problem, this is going to go away, and you'll be left with pi over 4. And pi over 4 is that answer. If you plugged a 2 in, right, 2 plus 1 gives you 3, and you get 3 pi over 4. So we are getting, if we plugged in 1, this will be 1 plus 1, which gives you 2. 2 pi over 4 gives you pi over 2. So we're getting our answers, but the one answer we're not going to get is this one, is this first one, which gave you 0. So that is one of the reasons why we don't necessarily need that second equation. It's all it is redundant. Okay, so we want to be careful when we have problems like that. Okay, so these were single trig function equations. What happens if we get a little crazy with our fifth example? So let's say that sine of x times cosine of x is equal to 1/4. And again, let's find it over 0 to 2 pi. Okay? Well, I don't know about you, but there's no way to turn a sine into a cosine or cosine into a sine. But what I do notice is it's kind of looking similar to 2 sine of x times cosine of x, which is the double angle for sine. So I'm going to make this become a double angle. So you can manipulate equations as long as you do it to both sides of the equation. So I'm going to multiply this side by 2, and I'm going to multiply this side by 2. And if I do that, I'm going to get 2 sine x cosine of x is equal to 1/2. And then this guy is now the double angle of cosine, or sorry, double angle of sine. So what am I going to do? Write my lovely let statement. Let 2x equal theta. So this becomes sine of theta is equal to 1/2. And all of these answers are going to be on your unit circle. Okay, so I get my two answers. So theta, when it's 1/2, should be pi over 6 and 5 pi over 6, first quadrant and second quadrant. We'll come up with two equations. So theta is equal to pi over 6 plus 2 pi n. And then second equation, theta is equal to 5 pi over 6 plus 2 pi n. Again, we're going to replace theta now with 2x. So 2x is pi over 6 plus 2 pi n. 2x, 5 pi over 6 plus 2 pi n. Again, we now have a 2 in front of this problem, so let's use our hypothesis of thinking that number kind of helps us figure out how many answers we should have. So if we use what we did on the first problem, just like that it had a 2 in front of it with the double angle of cosine, we should have 4 answers. So let's see if we get 4 answers. All right, so the first thing I'm going to do is I'm going to multiply everything by 1/2. And I'll do that over here as well. And what do I get? I get x is equal to pi over 12 plus pi n. I'm going to go ahead and change that to pi over 12 plus 12 pi n over 12, same denominator. And then this will become x is equal to 5 pi over 12 plus pi n. So again, I'm going to change that to 5 pi over 12 plus 12 pi n over 12. All right, so let's go ahead and plug in some numbers. So when n is equal to 0, I'm going to get x is equal to pi over 12, and I'm going to get x is equal to 5 pi over 12 over here. When n is equal to 1, so that would be 1 plus 12, so that would become 13 pi over 12, and 5 plus 12, that'll become 17 pi over 12. N is equal to 2, so that'd be 24, so 25 pi over 12, which, if we think about 2 pi, that's equivalent to 24 pi over 12, which means that doesn't work. And this side is also not going to work, so this would be 24 plus 5, so this will be 27 pi over 12. So again, that doesn't work. So we have our answers. So I'm going to say x is equal to, and I'm going to go in order, so pi over 12, 5 pi over 12, 13 pi over 12, and 17 pi over 12. Notice how many answers we had. We had 4, just like we predicted. Okay. All right, let's try another one. What happens if my problem looks like this? Cosine of theta minus 1 is equal to cosine of 2 theta. And this time, let's go back to degrees. We haven't done one of those in a while. So 360, 0 to 360. Okay, so on this one, I noticed that I have a single angle and I have a double angle. So let's go ahead and change it. And the great thing about the double angle of cosine is there's 3 ways to write it. I'm going to write it with the one that has the cosine in it. So I'm going to write it with the 2 cosine squared of theta minus 1. It's now quadratic. Let's move everything over to the other side. So again, from our trig equations from 6.2. So this will become 2 cosine squared of theta minus cosine of theta, and the negative ones cancel each other out. It's already set to 0, so let's factor. Let's pull out a cosine of theta, and this will be 2 cosine of theta minus 1. Notice that there's really no equation that I have to write a let statement or anything, so I'm just going to set everything equal to 0. So when cosine of theta is equal to 0, my theta is either going to be 90 degrees or 270. In this equation, this will be cosine of theta is equal to a 1/2, and so that is either going to be 60 degrees or 300. So x is equal to, we got a couple answers. So 90 is not first, 60 is first. So 60, 90, 270, 300. So sometimes our problem, right, does not require us to write let statements and solve for it, but again, we are using multiple angles with single angles. We're trying to get them all to look exactly the same. All right, we'll do a few more examples in the next video.